Hi, welcome to Nomis Academy. Today we are going to learn how to differentiate. So we are looking at differentiation from calculus. Alright, let's learn how to find the derivative of a function. Now a function is represented by y equal to f of x. We represent a function by y equal to f of x. Now, functions, as the name implies, are of different kinds. We have the linear function, we have the logarithmic function, and the exponential function, different types. Now, some of these functions, when plotted on a graph, will result to a line graph or a curve. Alright, now we want to know the meaning of derivative. What does it mean to find the derivative of a function? Now in differentiation, there are different mathematical notation we must familiarize ourselves with. The first one is delta y over delta x, or we write it like this, delta y over delta x. And we also have dy over dx. So we need to know the meaning of this notation. Mind you, either this or this, they mean the same thing. But this is totally different from this. We need to understand what they stand for. Alright, as a matter of fact, delta y delta x is simply called the slope of a straight line. Delta y delta x, or in this form, is simply called the slope or the gradient of a straight line. While dy dx is called the slope of a curve. Now we need to learn how delta y delta x will tend to dy dx, how the changes occur. Now let's pick a graph. We have a graph of this order. This is the y-axis, and this is the x-axis. And then we have a straight line, which is the line graph. Alright, just like I explained, delta y, delta x, or all over delta x is the slope of the line. We can also write it as m equal to y2 minus y1 all over x2 minus x1. Same thing as change in y all over change in x. So this is called the slope of a straight line, or the gradient of a straight line. Now when we have a curve that cuts this line on 2 points, we have this. The curve cuts the line on 2 points, point A and point B. Alright, at this point, we trace it to the x-axis. We have x1. And then from this point, we trace it down to the x-axis. We have x2. So the distance from here to here is what we call the change in x, or delta x. Y, this is called y. Another way we can write y is f of x. So we can also call it f of x. We can call it f of x. I need to extend this so that I can explain other things in details. Alright, so if this is delta x, we need to know what this side is, or from the starting to this point. So an arrow from here down to the x-axis, that's from point B down to the x-axis, is called f of x plus delta x. Meaning we added, remember, it's a function. Is a function. Y is a dependent variable and x is the independent variable. So meaning we need x in the function to give us the value of y. Now from B to this point is the function x plus delta x. Now we would like to know what is the value from this point. Let's call it point O, or point Q to point B. So we can also call this point from here. You see the arrow sign? That is from point B to point Q. So we can call it f of x plus delta x minus, we are going to subtract f of x from it. So that is f of x. So the distance from Q to B is f of x plus delta x minus f of x. Alright, now we would like to know, how do we get the slope of the curve? How do we get the slope of the curve? Now you know that the slope of the line is change in y all over change in x, which is also called delta y all over delta x. So we can write it like this. The slope of the line, line AB is given as n equal to f of x plus delta x minus f of x all over, that is this side, that is the distance from Q to B, all over the distance from A to Q, which is what? Delta x. So another way to write this, delta y all over delta x, is to write it in the function form, which is f of x plus delta x minus f of x all over delta x. Alright, this is the slope of the line. Now, how do we get the slope of the curve? Now, for us to get the slope of the curve, we can only draw a tangent, and then from the tangent, we get the slope of the tangent. The slope of the tangent becomes the slope of the curve at one point. Now, for us to do that, we can also use this. In this case, we call this line a secant line. We call this line a secant line. Then we need to transform the secant line to become a tangent line. This is what I mean. When you have a curve, a line that cuts across 2 points is called a secant line. Then if you can restrict this line to meet at or to touch at one point on the curve in this form, just at one point, and then it is called the tangent line. Now, for us to find the slope of the curve, mind you, we already know the slope of the line, which is delta y all over delta x. Now, we want to restrict this to become a tangent. Then from this point, we try to what? Drag down the line to the point that at this point, it is fixed in such a way that this line will only cut the curve at this point. In that case, delta x, which is this, becomes 0. So we are going to drag B in such a way that delta x becomes 0. So as delta x tends to 0, what we will now have is the slope of the tangent, which is taken as the slope of the curve at the point where they meet. So to do that, we say as delta x tends to 0, meaning as soon as you drag the line down to the point that delta x becomes 0, we will definitely have a tangent line. So we are now taking the slope of the tangent line as the slope of the curve at point A. So that will be in this order. Let me clean the board. So we take the limit as delta x tends to 0, we have f of x plus delta x minus f of x all over delta x becomes the slope of the tangent. So remember I said dy dx is the slope of the tangent line, which is taken as the slope of the curve at the point A. So that is how we are able to get the derivative of a function. So whenever you are asked to find the derivative of a function, mind you, you must first ensure that the function, when plotted, will definitely give you a curve. So whenever you are asked to find the slope of that curve, it will definitely result to dy dx as soon as you take delta x tends to 0 of the function, which is the slope of the secant, then it tends towards the slope of the curve. Alright, so at this point, I will stop, and then in my next video, I'm going to explain how to solve functions or how to find the derivative of the functions, derivative of different type of functions. So mind you again, I say dy delta y delta x, or in this form, is called the slope of the secant line. The secant line, the line that cuts across 2 points on the curve. While dy dx is the slope of the tangent line at point A, which is taken as the slope of the curve. Thank you for watching. See you in the next video.